Assalamualaikum warahmatullahi wabarakatuh. Today, my group project is about spanner. Our group is Dinesh Warren, Ammar bin Sharifuddin, Wanafi Hafizi, Muhammad Daniel, and Luqman Hakim. Introduction. Now I will present about introduction. A spanner, also known as a wrench, is a tool used to turn nuts and bolts. It has a handle and jaw that fits over the nut or bolt head. The jaw is then turned to loosen or tighten the nut or bolt. Spanners come in a variety of sizes and shapes to fit different nuts and bolts. They are used in a variety of industries, including automotive, construction, and manufacturing. Here are some of the most common types of spanners. First, open-end spanners. This is the most common type of spanners. It has a U shape that fits over the nut or bolt head. Secondly, adjustable spanners. This type of spanners can be adjusted to fit different sizes of nuts and bolts. Thirdly, socket spanner. This type of spanner has a socket that fits over the nut or bolt head. The socket is then turned using a ratchet or socket wrench. Lastly, top spanner. This type of spanner has a star shape that fits into top screw. For problem statement, there are various ways to manufacture quality spanners from existing manufacturing process in the engineering work. Thus, a proper manufacturing process is chosen to manufacture the spanners in this project. Meanwhile, the study of the use of suitable material to manufacture the spanners is also considered for this project. Consequently, this project focuses on the deciding on a manufacturing procedure of the chosen manufacturing process and focus about the material which will be used to manufacture the spanners. Thus, in order to determine the suitable technique, all sorts of solidification procedures and material analysis are considered and evaluated to determine the perfect manufacturing process. Now, for objective spanner. Firstly, we do spanner to find out the materials used to make spanners. Second, to know how the manufacturing process of making a spanner works. Thirdly, to identify defects that are likely to occur during the spanner making process. Lastly, knowing how to overcome the defect problem.
Assalamualaikum, my name is Ammar bin Sharifuddin. My ID number is MA20223. I will continue our presentation about design factor and type of material that have been used, commonly used in industries, and the material selection for our spanners. There are several factors that need to be considered when designing a spanner. These include the size of the nut or bolt, shape of the nut or bolt, material used to make the spanner, and the finishing of the spanner. These are some of the popular materials used for manufacturing spanners. First is carbon steel. Due to its high strength and durability, carbon steel is a popular material for spanners. It can take high torque and offers strong resistance to wear and deformation. Next is alloy steel. Alloy steel such as chromium vanadium steel provide better strength and hardness compared to carbon steels. They are frequently used for heavy-duty spanners that require extra strength. For the third one is stainless steel. It is known for its corrosion resistance and is commonly used for spanners in industries where exposure to moisture or chemicals is a concern. It may not be as robust or carbon or alloy steel, but it provides high resistance to corrosion and stains. And the last one is chrome plate steel. Chrome plating is often applied to steel spanners to enhance their resistance to corrosion and improve their appearance. The chrome layer also provides some level of hardness, making it more durable. Okay, we choose the chromium vanadium steel for the material for our spanners. It provides better strength and hardness compared to the other available materials in the market. It is a kind of alloy steel that comprises the alloying components of chromium and vanadium. Vanadium and chromium both improve the steel's ability to withstand hardening, and chromium aids in preventing corrosion, oxidation, and abrasion. Both carbon and chromium can increase flexibility, thus this gives the material to adapt high strength, hardness, and wear resistance. And chromium vanadium steel also has an outstanding qualities for tool manufacture. The quality and performance of items will be determined by aspects such as manufacturing techniques, design, and overall workmanship. Thus, chromium vanadium steel is chosen as the raw material for the sand casting process. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Hakim. ID number MA20235. I'm continuing presenting about the method processes that we use. There is the sand casting. Sand casting are mostly used to make parts at misconfigured form and parts with suggested high strength. Thus, the sand casting process is chosen due to its high possibility to produce spanners that are strong and long lasting. Sand casting is chosen due to its simple production processes compared to other existing manufacturing processes. Moreover, sand casting processes decrease the material utilization and waste, as well as improve performance and durability. Sustainable sand casting practices also include optimizing the design of the spanner. So next is fabrication process. First, pattern and making design. Designing the spanners and sketch out the pattern. Making fabrication using pattern, use wood, metal, and other component metal. Make sure the pattern contains jaw and then other characteristics of the spanner. Next, progression mold. Make the mold by combining two sides, which is the cope on top and the drag on the bottom. Fill each portion of the mold box with 1.5 the design. And the design should fit tightly while still allowing room for the motor metal to flow. Make a getter and riser system within the mold. There are channel and reservoir that enable motor metal to flow in and access this to exit. Next is molding. Fill the mold box pumping area with specific molding sand known as green sand. Pack the sand tightly around the design to the equation and detail application. Then remove any surplus sand and make channels and screw for the molten metal to flow through. Next is mold production. Align two parts of the mold box function with the top, which is the top. Next is to establish the tight seal. Secure the mold box using clamps or other attaching pins. So next is viewing. Heat the metal of the charge, which is CRB, colonial vanadium steel, until it smells and becomes liquid. When the metal is melted, gently pour it into the mold validating system. Feed the mold to the brim, making sure the metal reaches all the edges and cavities. This is sublimation and cooling allow the metal within the mold cool and harden depending on the amount of the cavity used. Is considered that takes sometimes the management somewhat quickly, which takes in moving the casting from the mold. This is the casting is ordered. Open the mold box carefully when the metal has gone. Remove the casting. We shape the spanner. Complete the jaw, handle, and other characteristics. Remove any lighting and material from the casting. Finishing to remove any rough edge or defect for the casting. We use items such as handle, fries, and sandpaper to record the design. The funny look would be polished or smooth the surface as needed. So some notes for the application process. It should be noted that the sand casting may be complicated and involve procedure that require specialized equipment and experience. So for me.
Hello, my name is Muhammad Daniel bin Zaini, MA20233. Now I'll present part result. As you can see, these are the table bill of material to manufacture spanner. The manufacturing of the spanner, as depicted in the table, can produce 1,200 units of spanner. The bill for the material and cost has been identified in the table. Firstly, the material used for the spanner is chrome vanadium steel, which costs about 15,670 ringgit because 1 kilogram of steel is around 22 ringgit and 50 cents, and the weight average of the spanner is 350 grams. The material being used for the spanner is suitable because it requires good casting properties and machinability. Next, for the components, the cost is 18,500, which are used with a high quality. The direct labor is 23,750, which the total amount of the direct labor cost is much more than wage pay. It also includes the payroll tax associated with those wage, plus the cost company paid medical insurance, life insurance, worker compensation insurance, any company match pension contribution, and other company benefits. The variable and fixed manufacturing overhead costs are 5,830 and 13,500 respectively. Last but not least, the total manufacturing cost of the overall rims is 80,250, and the estimate cost per product is 45 ringgit. That's all from me. Now I'll pass to the next presenter. Thank you.
A very good day. My name is Dineshwaran Annaki Kunasegaran and matrix ID is MA19091. So now I would like to continue with the presentation for our project. So I will continue with the sustainability part of our project. So as you can see, the sustainability is continued with the calculation of energy consumption, which is consumed by the machines of the sand casting process. So for the sand casting process, we hope to use three major machines, which are the melting furnace, grinders, and polishing machines. So in these three machines, each machine has its own individual energy consumption level. So for the melting furnace, for example, has an energy consumption of 75,600 watt per hour. The grinders has 1,500 watt per hour. Polishing machine uses a 7,500 watt per hour. So the total energy consumption of three manufacturing machines are 84,600 watts per hour. So using this watt per hour energy consumption level, we can calculate the bill of energy consumption per month. So the tariff category was obtained from the TNB portal. So as I said, the total energy consumption is 84,600 watt per hour. So for that we convert it to kilowatts per hour, which is 84.6. So from the 84.6 we times with 12, that means the operation hours per day with 30 days of operational number of days per month. So we get a 30,456 kilowatt per month figure. So from this figure we calculate the bill energy consumption or the total bill for that month, by partitioning the calculation into two, which is for the first 200 kilowatts per hour and the next kilowatt per hour after the 200. So for the first 200 kilowatt hour, the tariff bill category is 38 cents, and for the next kilowatt after 200 is 44 cents. So for the first 200 kilowatt per hour we obtained about 76 ringgit, and for the next kilowatt per hour it's about 13,342 ringgit and 90 cents. So the total bill for that month or per month consumption is about 13,418 ringgit and 90 cents. So the explanation: in order to manufacture the chromium vanadium steel spanner, the use of electrical energy is an essential source in manufacturing sand casting process. In this typical process, we use three different types of machinery with an operational hour of 12 hours per day. So about 30,456 kilowatt per hour will be used per month. So we determine the energy cost for the first 200 kilowatt of each machine's usage. So the kilowatt is then, as explained, separated into two, and the total final cost is about 13,480 ringgit and 90 cents. So the operational hours is about 24 hours per day, but since the manufacturing machine only operates 12 hours is only considered for the calculation. So Next, I would like to go to the conclusion, which is the final part of our presentation. So from the project's understanding, we can conclude that we have done extensive research and analysis on the current manufacturing method to choose which manufacturing method is the best to produce the chromium vanadium made spanners. So upon several analysis, we have found that the sand casting process was the best to manufacture the chromium vanadium made spanners. So why? The sand casting process is suggested as it is a splendid manufacturing technique with typical splendid properties to the spanners. So the sand casting process is usually used to manufacture most metal mates. The sand casting process is chosen so that the spanners will adopt splendid strength and high melting point. And moreover, complex geometries can also be made with low production costs, which gives low production price or low price to the customers. So thus we can deliver the customers with a low cost product without the compromise of any quality from them. So thus the sand casting is the best process to produce the chromium vanadium spanners. So it's all from us now. Thank you.